Hi guys, welcome to our Neuron Animation by Rish Jane, Izzy Joe, and Hannah Krasno. So we're going to start off by explaining neurotransmission very generally. So we're going to start off by drawing a neuron. So a neuron kind of can be imagined as an arm. So your hand represents the cell body, the dendrites, and all that, and your forearm would represent the axon, which leads to the synapse, and then it's connected to another arm. So it's just a bunch of arms connected together. That's another way you can look at it. So the axon is that middle bit. The dendrites are the parts that come off the cell body. We have the axon hillock and the cell body, as I mentioned before. Nucleus in the middle of that, and then the synapse terminals, which are connected to dendrites on the other cell. So we're going to go ahead and focus on the synapse and dendrites and where they combine. So there is a synapse, and at the end of the synapse are a bunch of vesicles. These vesicles are often filled with neurotransmitters, a common example being acetylcholine. And the synapses are also lined with a bunch of Ca2 plus gated channels, which will allow Ca2 plus to travel into the synapse. So when there is a signal received, the Ca2 plus channel will open and the Ca2 plus will go in, which will cause these vesicles to go to the outside and release. And when these neurotransmitters are released, they will go to these receptors on the other side, and they will start activating these Na plus ions. And these Na plus ions are going to start going through these proteins on the bilayer. And as they're going through this will cause them to start creating a voltage difference. And because the voltage difference is becoming lowered from what it was previously, the cell is going to start being able to send a signal through the fact that there's a difference voltage, which is going to cause it to kind of go through. And we can see that there's this threshold that they kind of have to reach. So if it doesn't reach this threshold amount of voltage, then it's not going to occur. But since it does reach this threshold voltage in this case, we can see that the sodium is going to start going through, and then in order to fix the voltage difference, eventually the potassium will be going through, and then using a co-transport system, the sodium and potassium will once again switch and reactivate it. So the toxin we focused on was botulinum toxin, which is also known as Botox. And the way this toxin works is it kind of stops acetylcholine from being able to function. So at the synapse, you're going to inject this gas into it, and that's what Botox is. It injects this gas, and that stops these acetylcholine from traveling into the muscle and causing a response. And as a result, the muscle, which is causing the wrinkle by contracting, is going to be unable to contract, and that's going to stop wrinkles from forming. Thank you guys so much for watching, and that was our neuron animation.